All right, so we're going to continue on now with solving proportions, and this is really the important part of solving proportions because this is how to use proportions in real-world problems. Right, so I'm going to start with this separate page. It's not in the book because I really like to kind of talk more about how to set these problems up. They're very common. Okay, you'll use them all the time. So here's an example of the entire 550 students at Ledyard Middle School. About 120 are opted out and not attending school right now. So if I have a class with 22 students in it, how many students would I expect to opt out? Okay, well, if there's 120 students out of the entire 550 in the school that have opted out, then what's the expectation of how many will be opted out in my class? That's the question. And anytime you're given two sets of numbers like this, this is the situation in this case, and what would the situation be if one of those numbers is changed? Can you calculate the other one? Very common situation, and it's all done by solved by using a proportion. Now, when I set the proportion up, I need to do, there's going to be three things that I know and one thing that I don't know, right? Because I'm going to have two fractions that are set equal to each other, two division problems that are equal to each other, and there'll be one of those things that I don't know that I'll represent with a letter, okay? So what I know here is that there's 550 total, okay, the entire school, 550, and 120 students opting out. Okay, and then in my class, I know I have 22 students, and I want to know, what I don't know is how many are going to opt out. Okay, this is how I'm going to set up my proportion. The two sides of the proportion have to be the same thing on the top and the bottom, the same type of number. So I'm going to do total divided by the number that opt out. For this one, this side is for the whole school, total over opt out. The other side must also be total over opt out, and these two numbers need to go together. So this one is for my classroom. Okay, so this one is the school, this one is LMS, and this one is my class. Okay, so the tops of both of these need to match up. The tops need to match up, and then what's on each side, they also have to go together. Okay. You could write these upside down, both of them. You could switch the sides of which one is on the left and which is on the right. But the key to writing a good proportion for real world problems is that the top numbers need to match, be the same type of number or go together, and the bottom numbers have to go together. In this case, total over opt out equals total over opt out. And the way I'm going to have you specify what's what here is by writing these words, okay? Write total over opt-out on one side and total over opt-out on the other. And you'll see this in the example that we did, okay? So once you set this up, now it's just solving a proportion like we did previously here in the lesson. We're going to solve by cross-multiplying, okay? So 550 times x, which I'm always just going to write like this, 550x with nothing in between them. Number comes first always when you're multiplying by a variable. And then the other side of the equation is 120 times 22. Use your calculator for all these. That's 2640, 120 times 22. And so then divide that by 550 to get your answer, and it comes out to 4.8. Okay, now it's not a whole number because the proportions may not always come out to whole numbers. But to answer the real world question, if it's 4.8 students, about how many students would I expect that to be? Well, that's about 5 students. So the answer to the question is about 5 students would be opted out or expected to be opted out in this one class of 22. Okay, this is how proportions work. You're given a ratio of one in one situation, and you're using it to figure out the ratio in another situation. All right, so let's go to the book now, to the examples that are done in there, and a couple got it problems in the book. So I'm on page 57, and of course you should have your book open and following along here, okay? So here it says the ratio of type O to non-type O donors at a blood drive was 37 to 43. That means there's 37 type O blood donors and 43 non-type O blood donors, okay? That's the ratio. How many donors out of 300 would you expect to be type O? type O is a universal donor. I'm a type O, okay? So the ratio, the one that they give you is 37 type O out of this ratio here of 37 to 43 tells you how many total donors there are. You have to add these two things together. It's a little bit tricky. This type of problem has this little extra step in. Okay, so that's why they add those two together. So what you know here is that there are 37 type O donors out of a total of 80. 37 out of 80. And so now you're trying to figure out, well, how many would there be out of 300? So that's how you set up your proportion. Type O over total, 37 over 80, equals type O over total. Out of 300, the type O's is I don't know what it is, right? So I use a letter variable to represent that unknown. So now there's my proportion. I cross multiply, 37 times 300 equals 80 times T. You can butterfly that if you're a butterfly fan, right? If you like drawing those circles in. Switch pens, because I don't know, for some reason these pens just alternate which one is working. Okay. Multiply 37 times 300, that's 11,100 equals 80 times T. Divide by 80 to get your final answer, 138.75. So the question's asking about how many donors. That would round to the nearest whole number to about 139. About 139 type O donors. Okay, so here's a got it problem. The ratio of 7th grade students to 8th grade students in a soccer league is 17 to 23. Okay, this is 7th graders to 8th graders. So if there's 200 students total, how many would you expect to be in 7th grade? The first part of this problem is you're looking for 7th graders out of total. So I need to know in the first ratio here, what is the 7th graders out of the total? So what's the total number of students here given in the original part? 17 to 23 is 7th to 8th grade. Well, this one again, you have to add. Okay, so we're going to have X is going to represent the number of 7th graders. Now, I don't make you write this definition of the variable here, but if you write this 7th over total equals 7th over total, what the things are in your proportion, then you don't have to write this. You do have to write these words down. It's important to keep your problem organized properly. Okay, so the answer is 40. There are 40 total students when there are 17 7th graders. There's 17 7th graders and 23 8th graders. You add them together, and that gives you a total of 40 students. That's what you're given. 17 out of 40 is 7th graders out of total, equals, I don't know how many 7th graders out of the total of 200. So there's my proportion, and solve this by cross multiplying. So 40 times X, butterfly for you again, 40 times X equals 17 times 200. 17 times 200 is 3,400. And divide 3,400 divided by 40 then to get the X by itself, and that equals 85. So the answer is there are 85 7th graders out of 300. Now, the book talks about, in the next section here on page 57, that you can also use a unit rate to solve these problems. I do not do this, okay? Though sometimes it's easier, okay? You can use the unit rates and write an equation. I'm going to tell you that I think the best way to do all these problems is by writing a proportion, okay? Well, I don't recommend this method, okay? Where they say, well, if 6 containers is $7.68, how are you going to find the cost of 10 yogurts? Okay. Now, we did these problems in the unit rate part, so it's not really a proportion problem. Okay. We could set it up like a proportion problem and get the same answer. Okay. And that would be that the price over the number of yogurts equals price over number of yogurts. Okay. So you know that $7.68 for 6 yogurts is going to be the same ratio as for 10 yogurts, some number of dollars that I don't know. C. Okay, so again, cross multiply to get 6 times C equals 768 times 10, which is $76.80. Divide both sides by 6, you get $12.80. It's the same answer as if you use the unit rate and then multiplied it by 10. Okay, and then this is a similar problem. Okay, JC bought 8 gallons of gas for $31.12. So figure out how you're going to get 11 gallons of gas at the same rate. So they go through this writing the equation. We're going to do this later on, so I'm not really too keen on covering this part right now. So you could just do this as a proportion. $31.12 over 8 gallons equals how many dollars for 11 gallons? Okay, and cross multiply and get your answer. Okay, this one is not as easily done as a unit rate problem. So this is a better got it. This is like the ones that you're going to see here to do for practice. Olivia typed 2 pages in 15 minutes. Okay, write a proportion. I'm going to ask you to write a proportion, not an equation. Relating the minutes and the pages typed to actually write a proportion to figure out how long it's going to take to type 10 pages. Okay, if she types 2 pages in 15 minutes, how long is it going to take to type 10 pages? Okay, so what we know is the ratio of pages to minutes, and what is a good proportion for this problem then? Pages over minutes, 2 pages for 15 minutes, equals 10 pages, and I don't know how many minutes. I use the letter M to represent. You can always use an X if you want to, okay? So now I have my proportion. 2 out of 15 equals 10 out of how many? Now this is one that's easy equivalent fractions. So you might, instead of having to cross multiply, you might be able to figure out what the answer to this is, because these are good equivalent fractions, because you can get from 2 to 10 by multiplying by 5, which means I can get this by multiplying 15 times 5, right? That's how you do these problems with the easy number ones with equivalent fractions. Right? So the answer is going to be 75, 5 times 15. But let's do it the safe way, which is by cross multiplying. So that means 2 times m is equal to 15 times 10. The cross products are equal. So 2 times m equals 10 times 15 is 150. Okay, so 2 times m equals 150. Divide 150. 2 times m is 150. Then m is going to be half of that divided by 2, or 75 minutes. Make sure in all these real world problems that you include a word in your answer. Word problems always have a word in the answer. Okay, so my answer for this one is Olivia should be able to type about 5 pages, 10 pages in about 75 minutes. All right, so here are some 4 more problems here at the end of this lesson in the book, page 58, guided practice. So 3 problems that are just straight solving a proportion, and then 1 more real world proportion problem. All right, so I'm going to let you put your answers in for these problems, and then I'm just going to show you the word. So number 1, k over 7 equals 32 over 56. Be able to do this one with equivalent fractions. The cross products, 56 times k equals 7 times 32, which is 224. And so divide both sides by 56, and k equals 4. Number 2. 3.2 over 9. Somebody the other day said, hey, can you have a decimal in your fraction? Yep, you can have any kinds of numbers you want, because this isn't really just a fraction, it's a division problem. So you can have decimals, you can have fractions in a fraction. See that later on, okay? So it's not a problem to have decimal numbers in these fraction problems. 3.2 over 9 equals n over 36. Cross products, 9 times n equals 3.2 times 36, which is 115.2 in your calculator. So 9 times n equals 115.2. Divide by 9, and n equals 12.8. Number 3, 41 over x equals 5 over 2. 5x equals 2 times 41 is your cross products being equal. 2 times 41 is 82, and so 5 times x equals 82, divide by 5, and 82 divided by 5 is 16.4. So there's your answers for these 3 problems. And lastly, the good one, okay? Real world problem. Trina earns $20.58 tutoring for 3 hours. Okay? I'm not going to write an equation here. I'm going to write a proportion to figure out how much she would earn for 2 hours or for 4.5 hours. Okay, so they give you it's actually 2 problems here. I'm not even sure, I don't remember what I put under here. So let's see. First, we set up our proportion. Okay, so the proportion is money over hours equals money over hours. Right? You could do it the other way around. You could do hours over money as long as both sides match. Okay, this side is the one we know, $28.50 for 3 hours. So how much money for 2 hours? Cross multiply. That's $28.50 times 2, or $57 for 3 hours. For it equals 3m. Divide by 3, and you get 19. Okay, so for 3 hours, for 2 hours, $19. Make sure you put a dollar sign in your answer. I skipped the 4.5 hours problem. I don't have that on here. So, but let's do it real quick anyway. So that one's going to be, let's use the easier numbers here. If I know she makes 19 in 2 hours, then she makes X in 4.5 hours. Right? So there's again, dollars over hours equals dollars over hours. 2X equals 19 times 4.5. What's 19 times 4.5? Got me? I'm going to run over to my calculator real quick, which is over here. And 19 times 4.5 is 85.5. Okay, so 2x equals 85.5. So divide both sides by 2. Half of 85.5 is $42.75. Are you sure? Yep. So x equals 42.75. So she makes $42.75 for 4.5 hours. Okay, so there's my 2 answers. Again, don't worry about the equation part. Okay, how do you solve a proportion? By multiplying and obtaining the cross products and setting them equal. Okay, there it is. Find the cross products, then solve the one-step equation. That's what happens here. All right, so need lots of practice. This is a great, important, real-world topic. So we'll do a good bit of practice on these.